Hey everyone, welcome to Sine Studio. It's Mohammad Jumaa again. I'm founder of Sine Studio, holding master degree of architecture from Beirut Arab University and bachelor degree from International University for Science and Technology. Work at senior architect. Hey everyone, welcome to Sine Studio. It's Mohammad Jumaa again. Work as Science Studio, holding master degree of architecture from Beirut Arab University and bachelor degree from International University for Science and Technology. So, I'm teaching the following courses like Grasshopper course, RHINO, Revit, V-Ray for RHINO, and RHINO. Today we will talk about the Grasshopper. So today our session is how to create complex shape with according to parameters that shape our geometry with logic and with complex form and with using tools like Grasshopper. So what is parametric design? Parametric design is a computational approach to architecture where design elements are defined by algorithmic rules and adjustable parameters. Rather than creating fixed forms, architects define relationships and behavior, allowing form to adapt dynamically based on environmental data, structural performance, or use defined inputs. This method enables creation complex forms, efficient and responsive geometry that integrate aesthetics with function. So parametric design separated into three sectors. In order to design your project according to parametric design, efficient and responsive that integrate aesthetics with function. So parametric design separated into three sectors. I think that's work now. That's work now. I think it's okay now. That should be because the speaker repeats the voice. Now it's okay with you? I think that's work now. That's work now. I think it's okay. Just a second in order to make sure everything is going correct. That should be because the speaker repeats the voice. Now it's okay with you? I think that's work now. That's okay now. I think that's solving problem. Just a second in order to make sure everything is going correct. That should be because the speaker repeats the voice. Still? It's okay with you? Or not? I think that's work now. That's okay now. I think that's solving problem. Just a second in order to make sure everything is going correct. Not yet? That should be because the speaker let me double check about it or not. If there anything's not correct there, I think that's solving problem. I think not yet. So now let me double check. Let me know if that's work now or not. If there anything's not correct there, I think that's solving. Let me hear. I think better. Now it's better without echo. So now let me know if that's work now or not. Okay, great. Not correct there. I think that's solving. Let me hear. Does that work now? Okay. So I can repeat everything if you want without echo in order to give you the whole information about the Sine Studio and the approach and how to work as parametric thinking. Yes, okay. So welcome to Sine Studio. I'm Mohammad Jumaa, founder of Sine Studio from Damascus, Syria. Graduated from Beirut Arab University, holding master degree in architecture and bachelor degree from International University for Science and Technology. Worked as senior architect at Parametric and as senior architect in real estate domain and founder of Sine Studio. So I'm teaching many courses like Grasshopper, RHINO, Revit, V-Ray for RHINO, and Jumaa. So today we will talk about the Grasshopper. Our session is about the Grasshopper and how to create complex form according to logical thinking, according to parameters, and how to shape our project with logic, not just with complexity. So today we will talk about. So what is parametric design? Our session is about Grasshopper and how to create complex form according to parametric design is a computational approach to architecture where design elements are driven by an algorithm rules and adjustable parameter rather than creating fixed form. Architect define relationships and adjustable. Let me see if that's
Element are diving by an algorithm rules and adjustable parameter rather than creating fixed form. Architect define relationships
and
design is
adjustable.
a computational
Just
approach to
let me
architecture
see if
where design
that's
elements are diving by an algorithm rules and adjustable parameter rather than creating fixed form. Architect define relationships
and
design is
adjustable.
a computational
Just
approach to
let me
architecture
see if
where design
that's
elements are diving by an algorithm rules and adjustable parameter rather than creating fixed form. Architect define relationships
and
design is
adjustable.
a computational
Just
approach to
let me
architecture
see if
where
that's
design elements are diving by an algorithm rules.
yeah, that's work because I open the YouTube channel there and watching that again. That's solving now. I think that's solving now. It's okay with you. Here, it's okay. Just double check about that one if that's okay with you. That work. Uh, because I watch the video, open the link on YouTube. So for that reason, there was an echo. Uh, yeah, here I close it and nothing there in background. Yeah, got it. I forget it. Okay, welcome to Sine Studio again. It's my pleasure to introduce myself again for you. So I'm Mohammad Jumaa from Damascus, Syria, holding master degree in architecture from Beirut Arab University and bachelor degree from International University for Science and Technology. Worked as senior architect at Parametric Studio and senior architect in real estate domain in Lebanon, and founder of Science Studio and tutor at Archibest. I'm teaching uh, I'm teaching the following courses like Grasshopper course, RHINO course, Revit course, V-Ray for RHINO, and Lumion course. Okay, so today we will talk about the Grasshopper. Today we will talk how to create complex shape according to parameters, not just like complex form without logic. So design with logic. That is the best thinking how to create the parametric design. So in order to design according to parametric design, it's not just like complex form or you have one unit and if you repeat the unit on all the elevation and scale it or rotate it or move it, you will get like parametric design. That's not logic. That's just about complexity. But about the parametric design that according to parameters. So imagine that you have a single box and you want to open a window. So if you control the parameters, the width, the height, the location of the window in that box according to parameters like according to environmental analysis, structure analysis, site analysis, user factor, or site factors. So when you try to open the windows in that box, that called parametric design. Not mean if that not complex, that's mean not parametric design. So what is parametric design? So parametric design is a computational approach to architecture where design elements are driven by algorithmic rules and adjustable parameters. Rather than creating fixed form, architect defined relationships and behaviors allowing form to adapt dynamically based on environmental data, structural reformers, or use defined inputs. This method enables the creation of complex, efficient, and responsive geometries that integrate aesthetics with function. So, parametric design divide into three sections. First sections is approach. Second one, inspiration. Third one, which is the tools. So in order to design according to parametric design, you have to follow this structure. First one, you have to define the parameter, like in this one here in the approach. Define parameters or factor from client or side and design a process that is the structure and the strategy of design according to parametric design. You need to calculate all parameters as you can, because the parameters are infinity, because you cannot count it maybe from environment, from sunlight, from wind, from daylight, from night, and maybe from like sight around, noise, emergency. You have many parameters that you can showing that according to diagrams. You can sketch your design and try to develop your design according to these parameters and try to sketch a drawing in order to solve that problem. For example, you have sunlight from this side, but your design is in like high temperature area, like in Arab country. So you need to avoid this sunlight. You will try to design that in different way. So by sketching and draw many parameters and draw many diagrams, you can understand how to solve each parameter, and then you can combine everything together. Second one, which is the inspiration. It's necessary to get a resource from nature because the nature is adaptive with the environment, adaptive with the structure. You can see the nature system like anything in the earth, animal or plants, or like any shape in the nature resource. You can see the adaptation, and that's the most important thing in a parametric design. How to understand the adaptation of that element. For example, if I have a case study, for example, like a bird, and that bird have like two wings, and that mean I want to analyze how that's work, how that's fly, what's the material, the behavior, the width, the height, the length. So you can understand the whole that elements in order to get the material, the shape, the behavior, the function, the structure. So that's the second one, inspiration. Not just copy paste from the nature to apply in your design. I saw many design, like for example, like I designed that is curvature form because I get inspiration from for example like shark or bird. That's not logical. If you want to make it that's logical, you have to make it that's like according to understanding for that animal, for example, like understanding how the shark, for example, that adapt with the environment, with his environment, and that is a good example for you in your project or not. The third one, which is the tool. Parametric design is not just in this time, because that's from many decades, because you can see Cathedral Familia without any computer or any AI assistant. In manual, they designed a complex form according to parameters and studied the environment. Second one, which is coding, like Grasshopper and another softwares. Third one, which is a new revolution, which is like AI. So the process of parametric design in order to apply to your project. Like the first one, define parameters. You need to define parameters to your project, then build relationship between all parameters together, from sun, from environment, from noise, from user factor, function, then generate many variation that which is like generate the first form, then another form. It could be from like Grasshopper or sketching, and try to analyze if that's it's good or not, generate variation. Then when you get the whole parameters into your project and try to analyze and optimize before finalize, you have to try to simulation or optimize to see if that's work with the site or not. If that not work, you have to generate another variation or to define more parameters like this. Maybe you're missing many parameters in order to get best result. Then you can finalize and fabrication. So how that's work like a grasshopper? So every 3D element starts from points. From 2 points, you will get a curve, then a closed curve, then a surface, then like a 3D surface, like a solid object, then you can edit that one. So if you change the location of this point, you will get the different result. If you change the length of this curve, you will get the different result here. And also you can get many variations from just one parameters. Or if you change many parameters like rotation, move scale, or location for the points or curve or specific item, you can scale it. You will get unlimited variation and mass generated. So here you can see in Grasshopper 3D modeling techniques like 3D buildings, like this one, which is designed according to modular and according to attractor point, attractor curve, use it there. And here architecture element, you can use a Grasshopper for architecture element like stair, which is the most critical elements in architecture because that should be 100% correct. So top architecture frame using Grasshopper like Big, UN Studio, Foster and Partner, Mad and Zahedin and other. So because like RHINO and Grasshopper really most powerful softwares for architect. You can dive from 2D to 3D, diagram, animation, rendering, 3D modeling, fabrication, 3D printing, CNC, all of them you can use RHINO and Grasshopper. And the another side, which is like BIM for Revit or Archicad, that another method, but we talk about the parametric design approach. So if your vision to work as parametric thinker, you can follow this software or use like RHINO and Grasshopper. That's really better for you. And also Sine Studio on all social media like YouTube, Facebook, Instagram, TikTok, Pinterest, LinkedIn, and other. So also I want to mention, which is like that's book, that is our book, which is Let's Play Grasshopper Together, Lean Parametric Thinking and the Parametric Tools, 200 exercises. You will understand, you will analyze, you will try to find the best solution and system for your rural project. And you can see here the contents about the structure of the book, like about Science Studio, about author, parametric design approach, introduction to Grasshopper, explaining each component, which is essential, then exercises, 200 exercises. You will explore everything related to Grasshopper from basics to advanced and use many plugins like Kangaroo, Flexibility, Bufferfish, Weaverbird, and other. So all these exercises we will see that in eBook. And another system here in this book, I will show you something there. For example, you can see how to open from zero, how to open and launch the Grasshopper and each component, how that's work. And also I want to show you, for example, any exercise. For example, that exercise, for example, you can see here the exercise and the logical thinking of that one from line SDL, like a diagram chart, how to get that form in order to get that one. That is a system. Before trying to look at the definition, you can analyze and try to do that by yourself. If that's not work with you, you can try to follow step by step the definition, and that is highest quality. Here you can see that is the highest quality PDF. And also with this book you can get access for all videos, which is in 7 minutes. Here in 7 minutes you can see here the exercise numbers 34 to 200. You can watch all of them on our website. Just when you buy the ebook you will get access to all these videos there. And also for additional, if you want, you can buy 200 GH file that is in 100, and you can see you can get all the GH file there is already there. I'm not included that inside the ebook because I want from you to practice, not just to copy paste. So that additional, if you want, you can get that one. And here we have the shop. All links there in the description. Here the ebook link, also that in the description. So that is all about the introduction about our lesson today. So let's start together our session today. So we will design like this stadium. So before doing anything in Grasshopper, it's really necessary to try to analyze that form, to try to sketch on. For example, like I have here like maybe rectangle or ellipse or circle. That is ellipse, not circle. Okay, here I have the first one and here I have the second one because that's changing there. So, and here I have the third one, which is here, and the last one, the fourth, because here you can see the fillet corner there. So the fillet effect also, that mean I have another one there. So that mean I have 4 essential curves to create that form. But here you can see I have like that curve in this direction. One of them to outside and another to inside, like that curve inside. Then I use some component, maybe loft, to create that form. But we start with the curve in order to create curve like this. So that is really necessary to try to analyze everything before start. So let's start together. It's really important when you want to work in Grasshopper. I advise you to split your screen into 2 sections. First one for review, second one for workspace. And also I advise you to install that plugin which is bifocals in order to see all the name above the component. So as I told you that before, each 3D object start from points. From 1 point I can get like from 1 point, then if I move at that point I will get another curve, which is create curve between 2 points. And here could be, if I array that one, I will get like closed curve. After that I can create a single surface, which is this one, then create a 3D model like that one. Then you can edit that box to get the final result. But always we start with the points. So here in RHINO, if you change the location of that point, you want to model everything again in RHINO. So that is like another software. But here in Grasshopper, if you change the location of the point, you will change the whole location of your project. So the same here, we will start with the construct point, that is, so you can see here the name above the component, that is for easier learner. And here the component which is called bifocal. And also advise you
to always keep the display draw icon and full name draw there, because if you make it that's like this, that's not good for a beginner, because you cannot understand, oh, what that is, PT, or another one, like for example, if I use another component, what is C or O? You have to put them out there in order to read that is a curve. So I advise you to put that like draw icon and display the full names in order to see the whole name there. So are you ready to start? Everything is clear with you? Okay. So we will start with construct domain in order to create our shape. So we need to create a rectangle in order to start our design. Rectangle, construct domain or construct point with the plane, that is this one here. And here really necessary to understand the unit, because here you will see here the unit is in meter in RHINO, and here the same when you use a Grasshopper here, you will use the following unit from RHINO. So that's mean 110, and here could be 65 or more. That is the main court, which is in green area. And another one here, we need to use offset surface or offset curve in order to get the boundary around the green area. Rectangle with the curve, and here in order to use the same component you have to install the plugin which is called Bufferfish. So now I can use like 22 distance. Here I got that curve. So now I want to make it that's fillet corner, not like sharp corner, because that is fillet corner there according to analyze. So for that reason I will use fillet corner. Fillet connect curve with, and here's the radius. You can add the radius there, so you can see the effect on. So now if I make it that 44 for example, and I will hide this one because I don't want to see that one, and then I can use offset again, like it could be 11. Here I have two curves, first one, second one. Then I can move it a little bit up in that direction, so you can connect the curve with geometry in order to move it. And here the motion in that direction, factor for how much you want to move it, and I will hide that again in the middle bottom. Here display preview, you will see that's one, and I need another one there. You can see here that one. So in order to create that one, I will use again move in that direction. But here if you analyze that shape, you can see that curve like the same with the base, not with the middle. So that means with that offset. So I want to get that curve, which is this one. Fillet with move, and here the motion. So in order to keep everything connect parametrically and correctly, because here if I make it that for example 22 and connect it that like this, if I make it that by wrong like minus or 7 or 8, that will be under that curve, which is the order of that curve is the number 2, but here that should be number 3. So in order to avoiding like this mistake at the least, I will add addition, which is like expression, adding the move here, adding move with the plus 11. So now, even if I make it that like 0, it will be the same at least or more, but not under the second curve. So now let's move to create that curve. So that curve location is good, but here you can see that's not the same wave, because here I have another thing there, like not all of the same plane. So in order to create like this, we need to use a graph mapper, because if I use directly move component, I will move the curve without any changing, like all the curve will move it up. So for that reason, I will use divide curve firstly, like could be 12, and here if I connect the count, I divided this curve into 12 points. Now if you move that directly according to z direction, move this point, all the point will get the same value. For example, 12, if I add 12 here, you can see all the points get the same value. So in order to make that not the same value, like random or according to graph or according to attractor points, so here we need to add another thing like graph mapper. So in order to use a graph mapper, just type graph mapper and install, and here you can see that graph without any data there. Just right click and graph type and make it that like Bezier or Gaussian or Sine. So the name of Sine come from here because the concept of Sine Studio, and how to change the curve from degree 1 to degree 3 with the same curve. That is the logic, how algorithm affect on the design. So we can use like Gaussians, which is like curve start like this and doing like this. So how that's work? So I will just connect everything, then explain that. So make sure most time when you want to use graph mapper, here graph mapper has left hand, which is the range. If you connect range, you can see that when I connect the range, you can see that divided into many red line there. So that is the effect on the curve. Let me show you. So here in Grasshopper, when I say that is 0, 0 is a number and data in Grasshopper. But here, because in count it's not numbered, you can use it at like 12. So if I connect that with a step, you can see the output range is 13, but here is 12. So for that reason, just you need to -1 in order to delete the 0 data. So now you can see here the output, which is 12 match with this one. So here is the left hand. The right hand of the graph mapper, which is 3 components: bound, remote number, and construct domain. So graph mapper connect with bound. Sorry. Okay. So graph mapper connect with bound in order to calculate the minimum and maximum value from this location to this location. You can see here start from 0, 0, and here 0, 1, and here 0, 1. And the maximum is 1, 1 there. So that is to convert that value according to the component. Like for example, here I study according to move. So now connect bound with source and graph mapper with value and target with construct domain. So construct domain, you can add like 2 numbers, start 26 for example, and also I will make it that double click, you can edit that slider, edit that one, you can increase the number here, like make it that many decimal there. I will keep it at 26, and I can Ctrl C, Ctrl V to get another copy there. So now I will connect both of them there, and because here I study with move, I study the curve, how that's move, so that number is 26 maybe, or 25 or 50 or 100 or 200. But when you work with rotate, that between 0 and 360. When you work with like scale, that means between 0 and 2, approximately 2 and a few more. Now map it, that is convert the minimum and maximum to be, the minimum will be 0 and maximum will be 26. That is remap number. Like convert that plane here in this chart, the maximum will be 26. Now connect them with the move. So you can see here that is move according to graph mapper. So how that's work? So that is a start from 0. You can see here the red line here is integrate at intersection with the curve. Here I have like intersection with the curve, that is mean I have value there. You can see here many value there from 0.6, 0.5, 0.6, 0.3. So here I have many data that intersection between red lines and the black one. So that means here this point, this one, here's the intersection between the black and red, and this point, which is this one. So if I move it a little bit right or a little bit left, you can see the effect how that's changing. So because here I use like round curve, so you will see that maybe start from 0 this one, and also in order to see the order of all the curve, you can use point list for all this component here, this component, to show you the order 0, 1, 2. I will make it that bigger. 0, 1, 2. So the number 7 and 8, which is here, 7 and 8. So 0 here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the same here in this book, you can see how we explain that the same. How explain that the graph mapper effects on the curve or the point move. Here's the points when the intersection between red line and black one, how that's projection or move it according to this graph mapper. So let's move again to our design. I will hide that everyone here, and here every component there I need, which is move here. I want to create a curve from these points. So in order to create curve from points, just type interpolate in order to get the interpolate. So here I have the geometry with the vertices. You can see here the effect that's work, and just I will hide everything before. That's one I don't need it. But here you can see that's not closed. In order to close that curve, just turn on the closed option. So type toggle to add toggle bottom, that when is false, that means like 0, 1, you can use 0 and 1. That's work, like turn off, turn on, or toggle to turn on, and you can see that is closed. So all the curve, first one, second one, third, are closed. So here I need to show you there is another curve, because here I have like fillet, because if I connect them with loft, you will see that without fillet. For example, in order to connect all of them with the loft, you need to follow this method. I will explain why a few later. So just make it as curve, flatten and simplify, then graft and simplify. Connect both of them together. And here I have 3 curves. So by order, that is the last one. And here I have the second one. And the base, which is fillet one. So now, if I connect with loft by order, you can see that it's good, but that without fillet. So that was without fillet, and you need to fillet it to get another shape there and add value there. That's not flat like this. So you need to add another curve there. So for that reason, we need to add another curve. So just hide this one there. And I will move this one in that direction in negative 2.5 could be. And in that direction. And here I got this one, but that is a projection now, the same. For that reason, I want to make it that a little bit offset inside. So in order to offset that inside, also the same, we need to make it that negative way, also 25 or 2.5, because here in meter. So that is our curve. So you can see here, first curve, second, third, and fourth. So fourth curves are ready to connect together. So now, if you connect all of them with the loft, you will not get like this zigzag effect, like one curves inside and another outside. So I will duplicate this one and added another one there and disconnect all of them. And here, let me see the order, because that is really necessary, the order. So now that is the last one, the third, the second, and the first one. So if you connect all of them with the loft, you will see that effect is upper, which is the fillet corner there, or the fillet edge there, like fillet, or round edge there. So now that is good for the shape. Just we need to adjust the graph mapper there in order to make it that in the middle, to keep it the same reference. And here you can keep it that in the middle like this. And also you can change the sort order of the points, but not in this time. I'll show you another thing there. So for example, now it's in the middle and it's okay for the design, but that's for the shape, the math, it's okay. But what about the zigzag effect there? We cannot see any effect of the zigzag. So for that reason, we need to add curves, like vertical curves, not just horizontal curve. Here we added like first curve horizontally, second one horizontal, third one which is horizontal direction, and the last one. When you loft, you will get like this mass. So so for that reason, we need vertical lines. Now we will use another thing. I will hide everything there and keep it them there. So now, in order to create like vertical line I will just add curve component just to order all my work. That is the last one, that which is the third one, and need the second one, which is this one after offset, and the first one, which is the fillet. So now I order everything there in order to work with the order first, second, and third. So now I will hide everything before to focus on our work. So in order to get like vertical line, we need to divide curve into many points. Divide curve, it could be 64 count. So it's really necessary because you want to make all of them with the same parameters, with the same count. So don't do like this, like duplicate the parameters, because if you change the number there, that will not affect on the second one. So I advise you to connect all of them with the same parameters. So now I will get another one and here. So that is second one, third one, and fourth. So you can see here four scale points, groups, and here we need to create like vertical line. If you use interpolate directly, that will not work, because if you connect that directly like this, you will create the same curve again. So for that reason, you need to convert from flatten to graft. So what's the difference between a flattened group and a graft group? I will show you. That's by using panel. So that is a flattened group. You can see here 0, 1, 2, 3. That is the number of points. 0, as I told you that before, that is 0 is a number like data, and here 33, which is 34 points. 34 points. And now all of them under one hidden line or dark title, which is like all of them in the same group. So when interpolate work with this flattened group, when you connect all of them together, so that means interpolate will understand all these points as one curve. So interpolate go inside that group, which is here, and read all data to get the curve. So when I converted that to graft, for example, that before using graft, here right click, use graft method, and you can see each point inside a group. So that is each point in group, and if you connect the point with interpolate, nothing happened there, because here interpolate go into the first group that found 1 points, and as I told you that before, to create line you need 2 points, so at least 2 points. So when you go to this method by using graft, you will interpolate will read the first group has just 1 point, second group has 1 point. That means when you see the wire is dotted, like each data has individually group, not all of them with the group. So now what we have to do is just to connect the location of the point and need to make it that simplify. I will show you what is the simplify, because here we created the first one with rectangle and another one with offset surface, offset curve. When you offset curve, you will get like many points. So for example, here I create in RHINO a curve from 1, 2, 3, 4, 5, 6 points. When I offset curve, like for example like 5, and here I got another copy. Here's the control points count here 5 or 6, but here you can see many points. So if I use it like rebuild, you will see how many actual points is 44. So for that reason we use simplify here in RHINO in order to like reduce the control point as possible. And also there is an option before offset curve. You can see here lose when it's not active will increase the control point. When you make it that yes, you will see that much the same control point. So for that reason we use like simplify, because we have different method here: rectangle, offset curve, and then moved. So the same here, flat, graphed, and simplify. And here I have 4 curves: first group, second group, third group, and the fourth. And now if I connect them by order, you can see that vertical line match the design. So it's good. And you can see here each curves is connected correctly. Do you have any question before continue? I want to see if you have any question for continue, to hear from your feedback. If I like explain anything quickly, I can make it that slowly. So no question there. Okay. So let's continue the shape together. So here I have many curves. So for example, if you want to loft all of them together like this, so here in order to loft all of them, it should be flattened, not graphed, because here is dotted. You can see that means each curve in a group, and we want to make it like flatten, to make all of them inside one group, and loft go into this group and doing that surface, because two conditions to use loft. First condition is to create a surface at least from 2 curves. Second one, it should be curves opens or closed. So now I have all curves open, and here in order to close that part, just add loft option, and maybe you can use like this, like closed loft, but I don't prefer to do that here hidden option there inside the loft. Just connect loft option with the option, and here the closed, just add like number 2 to close it like this. And here I got that one, but without that effect, which is like zigzag. That's good, and but that's without like zigzag effect like the reference here. So for that reason we need to use different thing. So before doing this one, I will hide this one again and hide this one. So now we want to work with this group. So that is okay. Let me highlight this one in order to keep your eyes on this component. That group we want to work. We want to make like 1 point inside and another point outside. So in order to make that, we need to use like horizontal frame. Horizontal frame, that is horizontal frames, and that is need a curve, that is a curve, and the count of that curve, it should be the same slider. That is really necessary, too much the same slider with all component. So that is, I don't want that anymore. I want to use horizontal frame. So you can see here, horizontal frame create like a plane on all points, because here in default you have like X and Y and Z in this direction. So when you have like rounded curve or curve like this, not in X or Y, so you need to use like this method in order to make that all the elements perpendicular, or move it according to perpendicular plane for that item. So if I move it, so you can see here the C plane for that point in this direction, but the default one in RHINO in this direction, but here in that point in this direction, another one in this direction. So that will be always perpendicular on that curve. So now we need to deconstruct plane here, deconstruct plane to explode or to get the direction from all plane there. So now here I have the points X, Y, Z direction. X, Y, Z direction according to this C plane, according to this one, not according to the default one. So now if I move in Y direction that directly like this, that will not help me a lot, because here you can see all of them move it with the same value. For example, 1 meter inside, all of them 1 meter inside, and that move according to the direction for C plane, not moved like in Y direction like this. So when you use Y direction, all of them in Y direction, you can see here that's not the same with this one. So that is wrong in this method. So now in order to make that not the same and to make it that's like zigzag, we need to use repeat data component. Repeat data component work like loop. If you add like 2 parameters to this component, that will apply on all the points. So for example, here I have 2 inputs. First one data, second one which is the length. The data, that means how much you want to move it, maybe 2.5 and 2.5 in negative. So that means I have 2 value there. So just to order your work, make it that in merge. Connect the first value, second value. So that is just to organize your work. That's not affect anything to use merge. So now I can connect that with data, but here the length, how many data you want to repeat. So here I have 34. You can connect that directly with the length, or use list length to calculate how many points you have. So here's the same, 34, and here 34, the same. Now if you connect with the lens, the same, and now we need to apply that with the move. So in order to apply that, we need to add like amplitude, which is called amplitude to connect vector, for example in Y, and the amplitude, the power of the value, you can connect with that one, and here you can connect them. You can see here how that's work. The first one connect 2.5, then negative, positive, positive, negative, positive, negative, to the last one, loop. If you add another one, for example, like here, you can see here the effect how that's going on, like negative or positive, negative, negative. That because here the indoor, which is the positive, according to C-plane, you can see here the green line inside, not outside. You can flip the curve in order to make it that's in another direction. But that's okay for now. And if you increase, you can see the effect on that specific points. The order, the third point, start 2.5, then negative 2.5, then added like that one, 2.5 here, 2.5, then negative 2.5, then in another one which is positive in 10 value. So now I will delete this one and keep it like this. So if you connect them directly, that will work, but we need to make it that's by using another thing. I will show you something else. So I will duplicate this one here and hide everything there because that not work with us here. And here just we need to replace, instead of connect this one with that point, just connect that is our points. So now that's work. If you connect with the interpolate, that work, but not the same effect. Here, so interpolate, I will show you here how that's work when I connect each one with the interpolate in order to explain all single details correctly. So here, if you connect the first one, interpolate, go into the first group and read just 1 point. So when you connect the second one, that means read the same line here, interpolate, go into this group, can read the same line, that continue the first group, the second group, the third group, fourth group. That means all groups will connect with the same lanes. So 0, 0, 0 will be the same, 1, 1, 1 will be the same. So for that reason, the order is really important. 4 points. So now if I connect loft, as I told you, it's really necessary to make it that flatten. You can flatten that from output or input, and loft option again, loft option. Okay, and closed option there. And here we got the curve. I will hide everything there because we don't need to see anything there. And I will make it that custom preview, add custom preview. And here I can add like real material that created in RHINO. I created many curves there, or many material there already there, like a gray material. I will use it. Your question is how cannot we use call button for this? Yes, you can use, but call button will divide it into two call button divided into two group, like one group and delete another one, and here you repeat the data because you can explore many things when you use repeat data. For example, for example, like skyscraper, I will show you an example for you as a list. Like you have like a tower and you want to make the first one the same scale, second one another scale, third one the same scale, and the sort will be the same. And when you use loft, you will see how that's waved or different scale. Now I will connect with this one, and you can see here the gray material apply there. Just when you click here in only draw preview geometry, when you select the component, you will see that is good. And here you can see that is inside, not outside, and this zigzag effect is good. But here, not just like zigzag, but also like oriented in another direction. So now, in order to create like this one, I will show you how to create like this. So now that connected by order. So for example, imagine that this is 0 number and here 0 from next one. I will show you that directly here. point list 2.5. And now if I connect them, you can see the order. I connect them there to show you. Plop, plop, plop. That's one, and here's the last. So you can see here, always 0 with 0, 1 with 1, 2 with 2, 3 with 3, 4 with 4. So in order to make that wave or oriented effect, you need to shift list, like shifting that lift in another direction. So in order to do that, we need to make it that like by shift the order of all the points. So now we will work with that one, which is this one, that group. So also before, connect them with the point and interpolate. Here we need, also I will hide everything there, and I will show you that one here. So here you can see the order 0, 1, 2, 3, 4 to the last one. Okay. Now if I use shift list, so here I have 3 input. We will focus on the first one, which is list. That means our geometry, our data, which we want to shift one. So just shift 2 times. When I shifted, you can see here 0 was there, and after shifting you can see 0 is there. Before 2, and here that's one here that was there before. So that is shift component, how that's work. So if you connect them directly with shift, I will use them for all to make it that small control, but just will make it that the first and second and fourth as 0. So now disconnect here and disconnect this one and disconnect this one. So just always keep it everything by order. Here and here this data. Tap Ctrl Shift to get the wire and connect with the component. So that is the first one, here the second one, and we can make it that's 2, and that is 0, and that is the last one. Okay, great. So now you can see the order, how that changed. 0, start there, 0 with 0, then 0 again to this one and here. So the order from the second curve is a change. The second group change. So that is a change there. So now if I enable preview and enable that component, you will see the zigzag effect there. So that is the effect is happened there. So now if I increase that parameter for divide curve, which is divided that curve and create vertical lines. So now if I increase, you can see the effect there, how that's work. If I increase it that like 65, and here use different shift list to keep it that 0, you can see that without orientation or like moving. So here when I use shift, you can see the effect there. So here the output is smooth. If you want to make it that like sharp edge, not smooth edge, just go to the loft option there and change the type from, like here you can see many type there, normal, loose, tight, straight. So if you make it that like 4, we'll make it that, so 4, which is like 3, 0, 1, 2, 3. that is the fourth option, will be like sharp edge, not smooth. If you make it that like 2 or 1, you will see that effect, how that's smooth on. So now that is our definition here, and I want to refine something there. So now we can add like this curve or add pipe there. Okay, no problem with that. So here we have already that curve there. You remember when we create that curve, that is this one, and just add pipe component, connect with the pipe, and the radius 2.5, could be more, could be less, that is your design. And here also you can connect them with a custom preview. So now we can add like more details, for example, like for green area and the stadium here. You remember that one, which is fillet corner here, that one, yeah, great. And that one, the rectangle one here, we will use like boundary to create a surface here, area for the surface to get a centroid, and then circle to draw a circle like 9 meters. Okay, that is our center. And offset curve 0.5, here 1 2 3, and we can now create another one for the middle circle there. And now we'll use split surface, split surface, or surface split. Okay, surface split. So here you can connect which is the cutter, that is curve, second one, third one here, and with our surface, that one. And here the output, many surfaces. So here just we need to use list item, make it that flatten, and here that's one, this is the first one, that gray material, and the middle circle will be gray material again, and here's the number 0 and number 3 will be a green material. Okay, so now use merge just to order our data. Merge again, this one and this one, and I will hide everything there. And here I got that one. So now just we need to add use boundary between this rectangle and the fillet one to add like the bottom surface and make it that as flatten, to add this one. And here if you want to add like an amphitheater, you can use this one here. You can scale it, or maybe you can use a scale. We will use different from offset curve, scale this curve like this, 0.5. It could be more to make the amphitheater there for stadium. That is the first one. And second one, from our curve in the middle, it could be here. That is, I think this one, or no, that will be after move, this one. And also we can use the same here, scale again and just to get the branch, connect with the centroid, and here it's good now. Maybe we can make it like scale here like this, and also we can use offset curve to make it that accurate between two curves. To use this one you have to install bufferfish and range to connect how many steps you want. So if that's not work with you, so here just install the bufferfish in order to use this component. And now we can use like extrude directly 0.45 extrusion, and here we can add like offset surface 2.5 or make it like 1. That's good one here, and that will be gray material. So for that reason I will connect them with this group. So before, here we have also this one is gray material, that is gray material here, and this one include all gray material. This one also is gray material about this one, and here the green one. Just take it here and connect. That's one here, and another one with custom preview in gray material or green here for the grass, and hide everything there. You can see the final result, and you can increase or decrease or change anything you want from that studio. So for example, I can change how many there, how many like surface there, or how many zigzag there, to make it like 50 or increase or decrease. So for example, you have here some issue there, so in order to solve that you have to make it like shift 0 or 2 or reduce the number, or change the loft type to make it that's 1 as smoother as you can. So I prefer number 2 and make it that like 3 for example, and increase the number, because when you not increase the number for the control for divide curve, I will show you here. So that's mean the first curve, when after shifting, here's that curve, when that is 0 and need to connect with another one here at up there, that is long distance from this one to another one. So for that reason the problem happened there. So now 61 for that design is okay, and also I will try to use different one. Here I can adjust the curve, like increase the number there or decrease the number. I enjoy when I use like Grasshopper. So here graph mapper also, and also if you want to has different effect, you can decrease the number of divide curve for the first one. You remember that curve here we divided and move it according to graph mapper. So in order to has different effect, you can use like 8, you will see 8 control point or 5, so you will see the effect is changed, but at least 3 points, because in order to create a closed curve you need at least 3 control points. So it could be 3, so you can see how the effect there and different design. And just if you want to adjust, just move it a little bit, like move up, and that's good, that's solved. And here you get another design there, amazing. And also you can use like different graph like sine many waves there, it could be many waves, and you understand the logic of that one. But because here I have just a 3, so that means I have a 3 red line, 3 effect from the one. I will make it that again. So you will see here when I use like a graph mapper again and change the wave, you see how that's effect there. Or change the graph mapper to Bezier. I prefer to use Bezier, Gaussian, and Sine. 3, I love it because you have approximately full control of the curve. And also, if you make it that flip it, you can flip the slider like this. And let me finish that one here. Yeah. So do you have any question about this exercise? I hope I explained everything for you in a good way and understand how to create like complex shape with logic and everything connect parametrically without any like problem, because when you want to see if that's work, if you change any parameters, that should be work with the whole like project. Do you have any question? So that is our definition, and I want to show you something about repeat data. Yeah, and the same here. We will use like construct point. And for example, like polygon 28 segment here, that is. If you want to make it like fillet or not, that refer to you. So for example, that is 0, and move it in Z direction series to create many curves like linear array. It could be 12 each step and count 10. That is our polygon there. And here you can use like repeat data here by using scale. I will use scale NU. Repeat data. So here repeat data, we have to read how many data there. We have 10. I prefer to use list length in this one. Connect list length with repeat data and merge to make it the same here, because we work with a scale. We will make it as 1.2. The first one will be the same one, and second one will be like 0.8. That is smaller. And the geometry, with geometry plane, we need area for each curve like this, centered with the plane. And here, if you connect the repeat data with X, well, that will affect in X. And you can see the first one the same, second one scaled in 0.8, third one scaled 1, like that order, 108, 108. That repeat loop to whole data. If you have 100, 200, 5 items, all that data will apply the same method. Repeat the data loop to change that size. So you can connect with X or Y. Then you use loft, and here you will get like that skyscraper. Gray material. And now you can add another one and add another one and make it that like bigger or smaller. So that is everything about today. And if you have any question, feel free to ask me anytime. even if you don't have like a subscription plan or you don't attend to the course, you can ask me anytime on YouTube channel or on my Instagram or on my WhatsApp. And also I advise you to get the ebook with playlist that offer a big deal for you in order to understand the whole concept and to follow how that's work and how to design according to Grasshopper. And make sure Grasshopper as a tool, not like that will design a studio. So you need to understand and to upgrade your skills in skills action and in academic side. So to combine the information and knowledge together, to combine skills and your understanding of the parametric design together. So not everyone who work with Grasshopper that mean designing according to parametric design. So you need to combine everything together. So do you have any question? I hope you enjoy in this session, and feel free to ask me anytime, and you can attend to the course or get GH file or get the offer, which is Grasshopper, RHINO, and eBook and playlist, all of them together from our website. That was Mohammad Jumaa. If you have any question, I'm always here ready to assist you. Thank you very much. Yeah, we're changing. Can you we're changing? You want to pull in which one was, for example, do you have any thing to like explain what do you mean like changing like topography or like curves to boolean anything? The boolean component need a closed object, or if you talk about the curves, you need to use like region to boolean all curves together. That is, and let me hide this one and go again to our design. So now I'm waiting for any question there, and I hope you enjoy. Yeah, building changes. Thank you so much. Most welcome. Yes, topography. Okay. Can the building change based on different topography? Oh yes, of course. I will show you something related to my work here in Lebanon. Everything like slope it. I will show you something related to topography here in Lebanon. Also, I create an exercise that about that 159, right? So you can see here the building, how that's effect on topography. So when I change the building and the rotation or anything of the building, you will see the effect reflect on the topography. Still going on. To be honest, it's still going on. If you want to get anything, you can get that anytime. Still, the Black Friday is going on, maybe 5 days or 10 days. No problem with that, and you can get that. And to be honest, my message not just to sell my product or to sell my ebook. My concept is to teach you the right way about architecture, about tools, and to give you all the information I know to you. Most welcome. So I think you don't have any question. So hopefully it was useful for you and enjoy in this session. This was Mohammad Jumaa.